Students, today we will discuss about how to solve sphere and rastinge problem using genetic algorithm available in genalg package in R. So let us understand the fitness function or objective function for sphere and rastinge. You can see the objective function f of x for sphere is given as sigma over I xi square. Similarly for rastinge, sigma over I xi square minus 10 cos 2 pi a x plus 10. Here x is a real valued vector. That means we have to use a real value representation of genetic algorithm. So let us go directly. First we will solve sphere problem using genetic algorithm. So since we have already discussed about this, so let us fix the range for optimization of x is 0 to 20. So let us see the syntax. This is the syntax for genetic algorithm function. Rbgea is the function, and the lower is the range of values, lower range of values for all variables, and upper is a vector consists of higher range of values for all variables, population size and iterations, how many maximum number of iterations you have to specify, and a monitoring function. So this function is generally called for every generation of population. And finally the fitness function. This is our fitness function. So we have already seen this is the function sigma over I xi square. So let us see. First of all, we have to load the genetic algorithm library by using this statement. Next we have to define the sphere function. Sphere function is equal to function of x, and you need to return, you can see this function, the first function sigma. So you need to apply the summation function, sum of x to the power of 2. Here x, you should understand, it is a real valued vector. So the implementation of sphere function is over. Next, define the maximum number of iterations. So you need to understand this. X is a real valued vector. Since in this question the dimensionality is not given, so I am assuming as a 5. Okay, and after that you have to call the genetic algorithm function by using Rbgea. First of all, first parameter is the lower vector, lower range of vector. So I already told you here the range is taken as 0 to 20. So you can see this. So we have taken a column vector consisting of zeros, that is a lower range. Similarly, this is a column vector consisting of a higher range of values. So here the higher range is fixed is 20. In between to 20, 0 to 20, we have to find the optimum value. Third one is the population size. Okay, population size, how many number of solutions, and then fix the maximum number of IT, how many iterations. So in this example I have taken as 100, so you can take 1000 also. And finally the objective function or evaluation function. So here it is a sphere function. Since we have already implemented it, you can call directly and pass it as a last argument. So when you execute it, it will throw you the output S object. So with this output S object, we have to print the best or optimum value and its corresponding fitness value. So for that, we are finding the index. Okay, which dot min, we want to find out the minimum value, minimum optimum value. So we are using which dot min function for this object, output object, yes dollar evaluations. So you will get the index. With that index you call the population. Actually it is a matrix, you can see. So once you pass on this index, you will get the appropriate population and its corresponding value. So after that we will plot the function, okay, and this plotting it will be, you will get the value between fitness value or evaluated value with reference to number of iterations, and finally print the summary of results. So let us execute one by one. So I am executing one by one. You can see the output. So you can see the output. We are getting the output. After executing this statement, we are getting this is the solution, optimum solution, and its corresponding value. Okay, and finally for plotting, you just execute it. You can see at the right hand side, you can see x-axis is the iterations, okay, and y-axis is the fitness value. You can see it is decreasing. Actually there are two curves in that, you can see, you can observe this. So one is the actual value and another one is the mean, okay, you have to understand like this, okay, and finally you can print the summary. Okay, let us see. So now you can see this, you can see the output here. This is the summary of the output object. What is the type and the population size, how many generations we evaluated, and how many elitism we have taken. See here, elitism means some populations are identified as elites and which can be passed on to the next population. So if you see the algorithm, you will understand it. And then the mutation probability is also taken as a default one. It is taken as 0.1. And finally, this is the solution, best solution we got. Okay. So with this understanding, we finished how to execute sphere problem using genetic algorithm. Thank you, students.